Welcome to our first lecture for ENG 301, Applied Electrical Theory 2. And so in this class we're going to be extending on some of the techniques that you learned in Applied Electrical Theory 1. So we're going to be looking at more ways to analyze circuits in different domains, and we're going to be looking at new types of circuits. Now for many of these circuits and components that we're going to be looking at, there's an important thing that we want to talk about before we get into any of these new techniques, and that's passive sign convention. And so this might be something that you've seen before, but I wanted to quickly review it just to make sure everybody's on the same page here. And so oftentimes I'll just abbreviate this as PCS so as not to have to write out the entire thing. So in this first sort of introductory video to passive sign convention, all I want to do is sort of just briefly define it, and then in some later videos we'll look at some examples of how that comes into play when you're actually analyzing a circuit. So I'm going to go ahead and write up the full definition, and then we're going to come back and sort of look at some of the key pieces. So our definition for passive sign convention is we're going to be considering the reference direction and reference polarity. So whenever the reference direction for the current is in the direction of a reference voltage drop, so if we have this case is met, then what we're going to do is we're going to use a positive sign. And where are we going to use a positive sign? Well, we're going to use a positive sign in any and all expressions that relate voltage and current. And so of course that's going to include things like Ohm's law. That's also going to include our power expression that you would have seen in 201. So P equals IV. So any expression that relates the voltage and the current. Okay, and then we have another case too. If this condition isn't met, then we just say otherwise we use a negative sign. Okay, so there's our full definition. That's kind of a lot. It can be useful to come back and reference this, and of course it's going to be in the notes posted online as well. But let's take a closer look at some of these key parts. So we're talking about reference direction for our current and reference voltage drop. And so we'll see in some of the examples later on, but basically reference is essentially just how we've labeled it on the page, on the paper, whatever it is we're working with. And it might be that if we actually go to measure it, that value might be negative. But for this definition, we're only considering those reference directions and reference polarities. So another important thing here is that we have the choice, well, not necessarily the choice, but we're going to be either using a positive or a negative sign. And so I should have, this should be positive sign. So let me just add in here, positive sign. And then finally, we see that where does this positive and negative sign come in? Well, it's any expression that's relating the voltage and the current. And so like we talked about, that could be our Ohm's law, that could be our power expressions. And so as the name implies, from passive sign convention, this is related to passive elements. So passive elements include things like our resistors, but as we'll see later in the course, it also applies to our inductors, our capacitors, and we're also going to use this for our sources. And so the implication of this, what I want you to get from this, is that there's not really any wrong choice. If you have some complicated circuit, you can define your voltage polarities and your current directions however you want. And as long as you keep passive sign convention in mind when you're doing Ohm's law or any equation that relates IV, everything will turn out all right. So let's just say choose current directions and voltage polarities. How you want. And there are no wrong choices if our passive sign convention is considered. So if we take into account passive sign convention and we add appropriate signage where necessary, then there is no wrong choice. So just quickly, let's draw sort of a generalized element here. So maybe I have some square that represents an element. So this could represent a resistor, an inductor, a capacitor, a source. So let's say we have some voltage defined across it like this, and we have some current defined going through it like this. So because again in our definition we're talking about reference directions, so in this case our reference direction for our current is given by this arrow here, indicating that the current is going from left to right. The reference polarity for our voltage is given by our plus and minus sign on either side of V. So in this case, our current is going through a voltage drop, and that's because it's going from a higher voltage to a lower voltage. So if we come back up to our definition, our reference current is in the direction of the reference voltage drop, so that means we're going to use a positive sign in any expression relating voltage and current. So for this case, we would use a positive sign for any and all of our IV equations. So now let's say we look at, it could be the same circuit element or maybe a different one, and we've just defined one of these things differently to be consistent with the notes posted online. Let's say we switch our voltage polarity such that it's defined like this, but our current direction is still defined as going from left to right. So again, we're looking at the reference current direction and our reference voltage polarity, given by these things highlighted in red. And so what we see is that now our reference current is going through a rise in the reference voltage polarity. And so if we come back up to our definition here, we can see now we're falling into this otherwise category, which means we're going to use a negative sign for any IV expressions. So here, from passive sign convention, we're going to use a negative sign for any and all IV equations. Okay, so that's the basic definition of our passive sign convention. In our next video, we're going to look at a simple example of how we can show that no matter how you choose your voltage polarity and current direction, that everything turns out the same.